Good morning, everyone. Welcome to another episode of Xa Talk Show. Today we are going to cover Emacs Lisp from the ground up for beginners. Okay, so this is going to be 1 hour. Let's check video check, audio check. I'm good to go. So it's going to be 1 hour, and the prerequisite. So this is for people. I assume you have already used Emacs for a month or two, so you are familiar with Emacs a little bit at least, because Emacs Lisp is going to be used in Emacs. So if you don't do Emacs, then it's useless for you. Okay, so I assume you already used Emacs for a month or two, and I also assume you are familiar with programming languages, at least one of them. Some familiarity. So I don't have to explain what's a variable, what's a function, what's data type, what's a string, so I assume you already know that. So that's the prerequisite. So this is for beginners. You never know any Lisp before. Okay, and so we're gonna so let's go to my website. So everything I talk about today is already written as a tutorial, xali.info. So you just go to xali.info or just search my name, Xali Emacs. You'll find my Emacs Lisp tutorial. So that's my website. So you go down and you can find Emacs Lisp. Okay, so Emacs Lisp, that's what we're gonna cover. And let me tell you let me tell you some background about Emacs Lisp, the language. So what you're gonna get, so if you are an Emacs user, and if programming is your profession or any kind of technical security, computing is your profession, and if you choose to use Emacs, which is very powerful, you want to master a editor, text editor, because that's your life, and Emacs is a good choice. And if you use Emacs Lisp is great to know, because it allows you to, for example, this is a HTML. You are looking at HTML file and show in browser. That's today's talk show. So I can do a lot of editing. For example, here is the Google ads. I can select them by matching the tag and delete them if I want to. And for example, I can, here, this block of code, you see, I just press one key. Okay, hold on a second. Let me magnify. I forgot to do some preparation. I need to magnify my buffer. So for example, this command I'm calling, you see, it allows me to change my font size. Let's say 20. Okay, so now it's easier to see. I forgot to do the preparation. So let's also magnify the browser. Okay, so now it's easier to see. Okay, I forgot to. Okay, so hold on a second. But anyway, so that command I just called to magnify, to enlarge the font, is the one of the command I wrote. So if you are Emacs, so if you know Lisp, it's gonna be a great benefit to you. Okay, so show in browser, and let me enlarge this window. I forgot to do preparation, so I need to make sure nothing is blocked. Okay, so hold on a second. So let me also start my command log mod, so you can see all the keystrokes I type and all the command I call. So for example, you see this text, I can make it a paragraph. You see that added the p tags there. You see, undo, do it. You see, so that command I just called is XHTML blocks to paragraph. You see, so this is the power of knowing Emacs Lisp, and especially if you are a programmer, you can do your refactoring your code in any language. It's very powerful. Okay, so that's the benefit you get for Emacs. Of course, there are thousands of packages already, but you can enhance them. Knowing a little bit Emacs Lisp will help you understand lots of things in Emacs, because the whole Emacs is actually just a Emacs Lisp environment. For example, all your init files. For example, I have lots of init files. For example, all your init files, all those are just Emacs Lisp code. It's just programming language code. Okay, so that's a benefit of Emacs Lisp. So let's make this one line. Okay, prerequisite, and okay, I showed you my Emacs website. We're gonna go through some of them, and let me tell you there are two major parts to Emacs Lisp, the language. Okay, one part is that Emacs Lisp, you have all the things every other language have, such as string, variable. How do you define a function? How do you define local variable, global variable? How do you do a loop, for loop, while loop, things like that? Those are the basic concepts in every programming language: Perl, Python, Java, Ruby, JavaScript, C, C#, Golang, and so on. So, okay, variable, functions, string, comments. How do you do a comment in Emacs Lisp? So all these things, formatting string, arithmetics. How do you do 1 + 1? Converting string to int or float or string to different types of the language, and variables and loop, if, then, else, and then you have data structures. In the Emacs Lisp case, you have list and vector. Vector is just like a tuple in Python. Then you have sequence types, getting technical detail, association list, property list. So that's a data structure, built-in data types in the language. And then you have functions. How do you define them? How do you define various forms of function parameters? For example, named parameters, optional parameters, default values for parameter. In this, in the Emacs Lisp case, you actually don't have that. But anyway, these are function. What's a lambda function? And then in the Emacs Lisp, you have the concept of a symbol. Maybe we'll go over that. Then, okay, so all these elements are basic concepts in every programming language. Okay, so this is one part of learning Emacs Lisp. Okay, so this is Emacs Lisp. I call it Lisp basics, because these are concepts available in every Lisp: common Lisp, scheme Lisp, racket scheme Lisp, or closure. Those are the major Lisps today. So so this is one part of Lisp, concepts that's available in every language. So once you learn this, you can just do programming with it. Now the other part, which is more practical and more important to Emacs Lisp, is Emacs specific Emacs Lisp. So what are those? Those are things like how do you manipulate the buffer? So in Emacs Lisp, in Emacs we have the buffer, we have the window, we have the frame, we have the background color, we have the syntax coloring. You see the current line is colored. How do you do that? You have also buttons. For example, this is one of the feature of Emacs that lets you customize Emacs without knowing much Emacs Lisp code. So you see those are buttons that allows you to search. For example, let's say anyway, so buttons, syntax coloring, and major mod. Let's close it. Close buffer. How do you do that? You see these concepts: buffer, cursor position, deleting text, inserting text. For example, I copy that and copy and paste. All these concepts are not available in a general purpose languages such as Python, Java, C, because so these are concepts. These are Emacs specific Emacs Lisp. Okay, and this part is the most practical. And in my past videos, I've done a lot of that, quite a lot, more than 10 videos. So, but I've never done a tutorial of Emacs Lisp fundamentals from the ground up. So that's what we are going to do today. So Emacs specific Emacs Lisp, and how do you write a major mod? So you have, cursor text editing, how do you insert, and what is interactive, how do you query user. For example, let's say I want to in Emacs, Control X, Control F, open a new file. How do you prompt user to get user to enter some path? That's a prompt. So how do you do that? Usually these things are not available in other languages. How do you do prompt? How do you ask user to input file path, file names, or regular expressions for searching, or what, a number or whatever. And so Emacs specific things. Then how do you run Emacs Lisp code in a shell? Run Emacs Lisp script in a shell. So Emacs Lisp can also allow you to run. For example, in Python, you can type Python Python script, something like that, py, right? You run it. You can also do that in Emacs Lisp. Okay, so all this. Okay, so this concept is more specific to Emacs. Okay, so we're gonna cover some of that. So let's move on because we have a lot to do. We already talked for 10 minutes. Okay, so let's try to move on. We have a lot of people today. So if you have a question for me related to this talk, just ask me and post my name there. Okay, so I can easily see it. So two parts of Emacs Lisp. One is generic, similar to every language. The other part is Emacs specific, such as cursor, text manipulation, cursor buffer, major, minor, mod, syntax coloring, GUI. How do you create a new window, new frame, or things like that. That's Emacs specific. Okay, now they actually, okay, so for the Emacs specific Emacs Lisp, there are also kind of two parts. One is all about text processing, and this is the most practical. Because, for example, every time you see me using Emacs, all these selection, delete or cut, paste. Let me show the pink window so you can see my command. You see, I want to select the whole list. So that command is /HTML select element. So let me show you the code. Okay, so for example, let me show you some Emacs Lisp source code. Okay, so you jump to it. So there it is. This is what does that. So it's not too big. Okay, so copy that. So copy new buffer, paste only 60 lines. Okay, and make it syntax color. So anyway, okay, close that. So let's go on. Okay, two parts to Emacs Lisp. So yeah, so for the Emacs specific Lisp, there are, again, you can divide it into two parts. One is text manipulation, which is the most commonly needed, the most practical. For example, everything I do today, and that's, for example, delete, or that's related to, that's part of text processing. Now the other part is about how do you control font. How do you for example, you see the color here is purple. How does it work? How do you make Emacs to color part of text purple, for example? And you see here is a line. How do you do that? So these are not text processing. These are related to syntax coloring, font, minor mod, which is Emacs specific concept. Minor mod, major mod. How do you create a major mod? How do you manipulate window frame size? How do you write a directory viewer, for example? You see, let me shrink you see, here's a directory. So Emacs can be used for a directory. For example, I can make a backup of this file, do it. You see, there it is. Here's a backup. And the command I just called is that. So this is not text processing, but rather more Emacs specific. For example, and how do you write a image viewer? For example, let's go to some image directory, so I can actually view some images. So this is our Xali forum. View image, PDF viewer, and so on. Okay. So let's begin the Emacs Fundamentals, the general purpose Emacs. Okay. Let's see. Okay, so let's begin to do that. So in Emacs, so what do you do is in any Emacs buffer, when you can start to write Emacs code anywhere. Okay, but typically you open a new buffer, you open a new empty buffer. That's too big. Okay, let's hold on a second. Yeah. So in general, let's just do this +2, 3. Okay, evaluate it. You can see that's the answer 5. So we just typed some Emacs Lisp code and evaluate it, and you can also do it here in any buffer. Any buffer, you can just start to type Emacs Lisp code, and you call a function, and you can see the bottom is your result. Okay, so you can see the command I called is eval last sexp. Okay, sexp stand for this word SEXP stand for symbolic expression. Okay, that's a tradition of Lisp name, symbolic expression. That's what this syntax is called. Okay, so you can start to type. Just usually open a new file and you can do it. Okay, so what? Okay, so so that's how you start to type Emacs Lisp. And now let me show you. So Emacs Lisp, the whole language syntax is uniform. Okay, unlike Python, C, Java, JavaScript, or Ruby, or PHP, any other languages. The syntax, like each construct have a different syntax. You have to learn it. So for loop has a particular syntax. While loop, you have a different syntax. You have parentheses in somewhere else. Then variable assignment, you have a different syntax. That's most languages are like that. But in Lisp languages, everything you see is basically parenthesized form. Okay, like that. Okay, I need to go faster because this way we're not gonna go anywhere. So for example, now you have a nested expression. Okay, so if you evaluate this one, you see the answer is 6 because you are doing 3 + 1 then +2. Okay, so in Emacs Lisp, everything is an expression. Okay, so maybe actually should we write it down? Okay, so maybe let's write it down. Everything is a expression. No statements. Okay, in other languages you have things like statements, and sometimes you have statements, expressions, different. Sometimes you have directives, which is another thing. For example, in JavaScript, you have this string ustrict. That's a directive. That's called a directive because that changes the language's interpretation. So in Emacs Lisp, everything is an expression, no exceptions, and no statements, no directives, no anything else. Okay, so that makes it simple, uniform. So Emacs Lisp family of languages is such that you learn one concept, it applies to the whole language. So there are only, a handful of concepts you have to learn. Then you already know the entirety of the language. Okay, that's Lisp, including Emacs Lisp. Okay, so everything is an expression. So what does that mean? That means everything returns a value. So for example, this 2 is an expression, this 3 is an expression, this whole thing is a expression. You can call it compound expression. So everything is an expression. Okay, then so let me tell you about atomic expression. So this 2, for example, that's an expression 2. This expression is called atomic expression because it's an expression that cannot be taken apart. That's kind of the smallest expression possible. So you can also evaluate this one. For example, I can call just like before, eval last sex. So you can see the answer in a mini buffer too. Okay. Now let me tell you, in Emacs Lisp, everything is for beginners, everything is printed into a buffer. Every output is printed into a buffer called the message buffer. So you can see the name here. So you can switch to the message buffer by Control H E. Okay, that's how we do it. So for example, let's do it again. Control H E. So that pops up this message buffer, and you can expand it. So every output will be there. Okay, so you have to know this. Okay, so everything is an expression. Then you have atomic expression, which is expressions that cannot be taken apart. Then you have more compound. Compound expression is always a nested parenthesis. Okay. Now that's it. That's essentially all syntax you need to know about Emacs Lisp. So again, let me show you some Emacs Lisp source code. For example, you see this my HTML mod, okay, XAR HTML mod, which is 5,000 lines. You see all the parentheses, all those are expressions. So what does the expression mean? Expression, again, it means it returns a value. Unlike some other languages, Python, maybe not Python, in many languages, in C, for example, x equals to 3, that's a statement, and it doesn't return anything, or maybe you call it void. There's nothing like that. In Emacs Lisp, everything is an expression, okay? So make sure I'm on the page with you guys. So everything is good? Okay, so everything is an expression. So let's go back to next. We need to go much faster. Okay, so but there are like 5 exceptions. Okay, so how do you do comment in Emacs Lisp? Comment is comment is that, okay? Comment is the semicolon to the end of a line. This is a comment, okay? So now there's a question. Now apparently this syntax for comment is not parenthesized. So, it's like, oh, this is a new syntax I have to learn. Yeah, that's true. So, so there are few, maybe 5, a total of 5 or so, special syntax. Comment is one of them, but usually you don't have to worry about it. For example, another one is this apostrophe, which stand for. Let me just go over. Okay, so this is not critical. You'll know it once you get to know Emacs Lisp. So for example, this line is equivalent to this line, okay, quote something something. But however, you have a special syntax of a quote in front. That's a special syntax. There are only 5 or so of them. But all the rest are just either parentheses or just atomic. Okay. Okay. So let's move on. So text. Okay. So text processing, everything is an expression. Syntax shortcuts, yeah. So there are a few exceptions, but you don't have to worry about them. When you start to learn Emacs Lisp, okay. So yeah. So let me cover how to evaluate code. Actually, we did before. So there are many ways. Okay, you can also evaluate a file. You can say, for example, load. MetaX load file. Okay, then Emacs will ask you to type of file path for Emacs Lisp file, a script. So cancel that. So there are many ways. So again, in my tutorial, everything is covered here, okay? How to evaluate Emacs Lisp code. And the 2 most important thing you want to know is this one, eval last sexp. That's the most convenient. And what you do is you move the cursor to the end of the expression, then just call it. For example, let's say I want to evaluate that. I can put a cursor here or anywhere here, just after it. So I just do it. Control XE, that's a default key. Oh, okay, I removed it. Okay, so let me just use XAR. I'm using XAR flag keys. So anyway, let me do it. So you see 5. So show the message buffer. You see 5. That's the result. Okay, and again, you see the command is that eval last sixth. Okay, that's one of the most important command to evaluate Emacs Lisp code. The other one is called eval region. So for example, if you want to evaluate this part and this part, you select them first, then you meta x eval region. Okay, do it. Then you can go to the message buffer, and when you eval region, it doesn't show the output. I don't think so. So I don't think so. So eval region again, yeah, when you eval the region, it doesn't show the output. But you told Emacs, Emacs has already evaluated them. Okay, so that's how you evaluate Emacs Lisp code. Okay, so let's see what's next. Okay, so basically that's the beginner's introduction. So we covered comments, and let me show you. So I hope you guys, after so far, I hope you guys already know you can start to code Emacs Lisp already. I hope you guys take this seriously, so you can start to code it. You can already, from what we covered, you can already start to code Emacs Lisp. Try try to do some arithmetics. Okay. And we covered comments, we covered how to evaluate Emacs Lisp code, we covered the basic syntax of Emacs Lisp. Okay, that's a lot. We are already beginning Emacs experts. My power drink with some lime stuff in it. Okay. So it's very hot today. It's California heat wave today. Okay, so what we're gonna do for the rest of the another 30 minutes is cover all the language details. Okay, so we covered comments. How do you print? So, okay, let me show you. How do you print? So again, there are many ways to print. There's insert, there's messages function, there's print. Okay. Before we go further, let me tell you, so syntax is all parentheses, right? And the way you evaluate something is always a function call. So in Lisp, when the syntax is always F A B C, something like that. And the way you do computation, the computational model of Lisp, is always a function call. So there is no for loop, for loop in C, in JavaScript, you have a special syntax, and it's not a function, but in Emacs Lisp, everything is of this form, parentheses, function name, and arguments, okay, parameters, a function call. That's how you do computation. That's the computation model of Lisp languages in general. Okay, so the input are the parameters, the arguments. You pass whatever data you want to change. Then you call the function. The function, outputs some value, a new value. So this is how you do computation in Lisp. Okay, in Emacs Lisp, in Common Lisp, in Scheme Lisp, in Racket, in Closure. This is the computational model. Very simple. There's nothing else. There's no special thing. There is no iterators, there's no generators that return something mysterious that no such thing. Everything is just the value, function call, input, output. Okay, so function. Okay, so how do you print? The most important thing in every language. Okay, so there are many ways. Again, a function call. So you call messages. Okay, a string. Okay, hello world factorial. Okay, functional programming. So this is how you print. So let's evaluate it. Let's show the pink window. Evaluate it. You can see the bottom. That's the output. Okay, so let me show you. You see there. So this is how you print the most frequently used version. Okay, there are other ways, but we are not going to go over. Okay, let me go show you another one. The other way is insert. Okay, insert, when you call it, it'll just insert the string into the buffer wherever it is. Okay, so for example, let's evaluate this. Okay, there it is. Okay, let's try something more fancy, and \n for a new line. Okay, now let's delete that, evaluate this. Okay, let's insert. So this is how you print message and insert, most important. Okay, now let's go back. Okay, so now string, very simple in Emacs Lisp. Again, in Python, in Ruby, in other languages, you have double quote. You might have single quote. And in Python, for example, you have triple quote, and in Python you have. Okay, let's go over this. Then you have triple single quote. That's the Python case. In JavaScript, you have this template quote. Okay, the different syntax. So in Emacs Lisp, there's only one quote creating string quote syntax, double quote. Okay, nothing else. Okay. So let's delete that. Okay, let's leave them there. So for okay, just double quote. Okay, and here is how you get the length of the string. So let's magnify. So this is, again, remember, everything is a value, everything is an expression in Lisp, everything is an expression, and the only way you do computation, the computational model of Lisp is called a function. Give it input and get output to change the value. That's how you do computation. So right now we want to get the length of a string. What to do? A function. Okay, there, for example, length ABC. Now show the pink window and evaluate it. You can see 3 at the bottom. Okay, because you got 3 characters. And okay, and this can have Unicode characters. Okay, let's, for example, let's say that one. Okay, so evaluate it. You can see character 1 because you have 1 character. So you can have Unicode too. It'll work. In JavaScript, in Java, you'll get 2. That's because very complicated Unicode, UTF-16 encoding, because you are not actually. Anyway, so Emacs Lisp, okay, string. So now you know how to create a string, and everything, and because everything you do, everything is an expression, and any time you do want to do some computation, is always a function call. So now you already know everything you need to know about manipulating string, almost in Lisp. That's basically everything. Okay, so everything. So then, of course, so you have some escape. For example, how do you have a double quote inside the string? So you need to escape it. That's a fundamental. So how do you include a new line? So that's how you do them. Okay. But other than that, so there's there are some detailed complexities. For example, how do you include a Unicode or emoji but without literal emoji? Sometimes that's needed because for some characters that's invisible. For example, unbreakable line break. For example, there's this character in Unicode called non-breaking space. Okay, let me show you. Okay, so you can see, you cannot see it. In Emacs it shows a tiny underbar to indicate there's a character, but now you can call describe char. Okay, let's call describe char. So you can see the code, the name is no breaking space. So that is used as a space, but it indicates to the editor or browser or whatever to not have a line wrap. Anyway, so that's a kind of invisible Unicode. So for those characters, sometimes you need to use a the ID for the character instead of the literal. But anyway, that's a detail. Okay, you won't, most of the time you won't need this. Anyway, let's get back to string. So string functions, that's the most important. So we already showed length. Here's how you get substring. Here is how you join string, concact. Here is how you split string, turn a string into a list. Okay, and there are many others. There are also regular expressions and so on. Okay, but the thing I want to say again, everything is an expression. And in this, there's only one way to quote string, double quote. Okay, so everything you need to do with string is just a function call. So we have a list of all string functions here. This page contains them all. There are about 20 of them. Okay, so let me show you a few. Let's show a few. Okay, so length. So let's comment that out, those Python and JavaScript things. Let's write it out. This is JavaScript template quote. Okay, there's something like that. I have a tutorial on that. I have, by the way, I also, okay, let me mention I have so if you are new to my videos, I have, I write tutorials. That's my hobby, that's my obsession. Programming languages, study of design of programming languages is my hobby. In particular, the syntax of programming language design. So I have tutorials for beginners or even for advanced people, advanced programmers, all the tutorials for different languages, Lisp, full-time language, HTML, CSS, JavaScript, SVG, and so on, PowerShell, and Python, and Golang. So I have a tutorial on all of these in detail if you want to read them. So here are some examples of strings in different languages. So here is how you print. What's next? Okay, so let's move on to next. So string, substring. Let me show you how to do substring example. Okay, substring. Move the comment and print to the top. Okay, so some evaluations there. Okay, let's go here and save this file. Let's save it xxtodaysdate.el. By the way, the Emacs Lisp file name extension is .el. So if you want to save it, name it something .el. Okay, so now we save this file. Yeah, substring. So substring, I have a shortcut. Okay, yeah, there. So substring. So here is the syntax. Okay, what about how do you look up the documentation for a function? For example, substring. If you are not, right now I'm using XAR Emacs Lisp mod, my own customized major mod in Emacs for coding Emacs Lisp, but there's a built-in Emacs Lisp mod. Okay, so if you want to, I learned, I can use substring, but what is the syntax? What is the argument? So you can, what you want to do is describe function, meta x describe function. So the shortcut is Control-H, F. Okay, so it asks you for describe function and default to substring because the cursor is on it. So enter. So here is the documentation for and the syntax for this function. Let me shut down my phone alarm. Okay, never mind. My phone alarm is on. Okay, so we have a lot to cover. If you are on Sunny Discord, I can send you. Okay, yeah. Thank you, guys. So substring. So how do you use it? So let's demo. Okay, substring a string. Okay, let's say A B C D E F G. From, let's say from the first character, 2 is optional, so we don't need it. That means from the first character to the end. Evaluate it. What? Wrong type argument, integer 1. Okay, the second argument. Okay. So here is an example of syntax error or some error. So so when you see it next time, Okay. So all you have to do is just type Q to cancel that. So because the second argument here should be a number, not a string. Okay, so let's give it a number 1. Okay, now let's evaluate it. Okay, so you can see in the mini buffer. So let's go show. You see, it says B, C, D, E, F. So the 1 is gone. So that's how you do it. Okay, let's do another example. Let's say 3, and let's eval. So you can see now it's D, E, F, G. And let's do another example. This time, just to show some Emacs Lisp coding. So we want to check if they are equal. So D, E, F, G. So now we are checking if this evaluate to that. Okay, evaluated T. Okay, so you can see to go to the mini buffer, you can see T means true. Okay, so we covered string, and format string we're gonna skip. Okay, format string is a very frequently used function. So let's show it. So hello, we already showed this, so that prints hello. But you can, if you have some arguments, let's say 34. Okay, so hello, I have something as cats. Evaluated, you can see the output is hello, I have 34 cats. So this is how you, so this is a template kind of. So this means you want to turn something into a string, and you put the argument there. Okay, so that's the format function. Okay, and if you want to see the doc again, describe function. Okay, there it is, describe function. So it shows what? Hold on a second. Yeah, so it shows the inline documentation for this function with full explanation of what S means, percentage S, percentage, Okay, so that's format string, important. So arithmetics, let's skip. So it's, very simple. Plus for addition, minus for subtraction. Okay, and then you have multiplication and division. Okay, that's arithmetics. Now let me pay attention to this one. Okay, so here. So if you divide two integers, 7 divided by 2, you'll get 3, because not 3.5, because integer, because when both of them are integers, it returns an integer. Okay, so this is something you will have to watch out. In Python 2, it's similar, but in Python 3, they changed it. They changed it to automatically return a floating point, 3.5, 7 divided by 2. Because this default behavior is quite unintuitive, and to people. So anyway, arithmetics in Emacs Lisp. Okay, converting int to float. Okay, this is how you convert a number, an integer or floating number, decimal number, to a string. So this is how you do it. So you call the function string to number and number to string. Okay, we can, we don't need to demo it, but okay. So let's show the message buffer. Watch it here. So I evaluated. You can see it's 3. You see now, originally it's a string. Now it's a number. Now in this case, I evaluated. You can see now it's a string. Okay, so string to number, number to string. That converts string to number. Or you can use format. Format will convert a. Let me show you. Okay. Format will let you convert a number to string. Do it. Same thing. You see, 34 is a number. The output is a string. Okay. So we covered string. Then, okay, Boolean. Now Boolean. Yeah, okay, let's talk about Boolean. But let me first of all talk about the types in Lisp. Okay, for example, many languages such as Java, C, C++, C#, and Haskell, each value has a strict type. for typically int, float, double, long, things like that. Now in Emacs Lisp you also have those types, but they are not so significant. So like if you, for the first year coding Emacs Lisp, like you don't have to really know about them. Okay, you just be aware that integer, int, and float are different types. For example, we have demonstrated. For example, let's do it. 7 divided by 2. Okay, evaluated is 3. Okay, now let's try again. 7 divided by 2 point. Evaluated. Okay, you have to, point is not enough. You have to say 2.0. That makes it a float type. Okay, so if you do it, evaluated 3.5. You see, so why is it different? Because Emacs Lisp actually have a data type concept. So because the 2 is int type and the 2.0 is a float type, so that's why you get different results. So the point is that Emacs Lisp do have the concept of types, but it's not, other than knowing int and float, and other than knowing these cases, almost just 1 or 2 cases like I just showed you, you usually don't have to worry about it. Okay, like converting string to number 2. Yeah, so usually you don't have to worry about it. So I'm not covering them because usually, it's not something you have to specifically to spend time to learn it. You'll just know it. Okay, then when you need to, you can always go to the Lisp reference. For example, let's click on Arithmetics. Then there's a link to the Emacs Lisp manual, which is 1,000 pages. Okay, more than 1,000 pages if you print it out. It's a thick book. So here they will tell you the details about the number types and whatever types. Usually it's hard to understand. So you have integer basics. You can see lots of so you have integer basics, you have floating point basics. Then it mentions IEEE standard 7542019. Then you have types like double, and it mentions C data type double, and don't worry about them. If you want to get on, so my goal, I hope to show you that, is that you can learn Emacs Lisp and be productive. You could learn Emacs Lisp for the sake of programming language study. Yeah, that's one thing. That's good. But if you want to do that, your time is better spent on Haskell. Okay, Haskell or Camel, Erlang, those kind of languages, or Common Lisp or Racket Lisp. Okay, you don't do that. For Emacs Lisp, your goal is to be able to start to write your own custom functions for Emacs Lisp. So you'll enhance your Emacs using capabilities. You can do lots of things custom, only to you is useful. That's the goal. Okay, so don't worry about the details. You'll learn them eventually if you keep at it. Okay, so far so good. Am I doing good? Give me a high. Give me a high five or something. 7 people watching. I hope I'm not too slow. Okay, so 50 minutes. Okay, let's go on. So this few more things. We're gonna 1 hour today. Okay, so string, arithmetics, so Boolean type. So in Emacs Lisp, you don't actually have a type that's Boolean. Boolean means true and false. So instead, so you don't have a dedicated type of that. Instead, in Emacs Lisp, just remember this value. There's a special value literal called nil. Okay, this value is false. Anything else is true, but also this value is equivalent to a empty list. Okay, empty list. We haven't covered list yet, but we'll cover it. But anyway, just remember these two are same. Okay, so for example, we can type equal empty list versus nil and evaluate it, you can see it returns t. T means true. So remember, nil is false, and empty list is equivalent to nil. So empty list is also false. And by the way, another way to write the syntax for empty list is this, okay? Is apostrophe parentheses. That's equivalent to this empty list, okay? So if we evaluate this, it's also true. You can see in the mini buffer, okay? It's also true. So nil and empty list, that's false. Anything else is true, okay? Just remember that. There's no dedicated Boolean type in the Lisp, but true or false is determined this way, okay? That's about it. So let me tell you what is nil, okay? So nil is a variable, and the value of this, it's a built-in variable, meaning that by default it's already there. And the value of this variable is a symbol called nil, okay? Now, symbol is a special thing in Emacs Lisp. Again, for beginners, you don't worry about it too much, okay? Just know that there's a thing called symbol. Maybe we'll cover it today. So nil is a built-in variable. Sometimes it's called automatic variable. Anyway, it's built-in. It's already there, and the value of nil is the symbol nil. Essentially, it just means false. Okay, that's all it matters. Okay, it's just false. So you can use either one of them. So for example, we can also do nil equals to nil. Is that true or not? True. You see, it's just the same thing. Okay, and so nil is false. Okay, that's just a built-in variable. And true, anything else is true. So how do you represent true? For example, 1 is true. For let's say 2. Okay. Let's say AND. Okay, so in Emacs, AND is the logical AND. Okay, so for example, nil and 3 returns true because one of them is true. So let's evaluate it. Wait. Oh yeah. Oh, so you have to say all. Okay, evaluate it. You can see the result is 3, meaning it's true. So anyway, nil is false. Anything else is true. Okay, nil and the empty list is false. Okay. Now, but by convention, when you want something to be true, usually you use a symbol t. Okay, again, t. Let me show you. Okay, t or t. So okay, let me show you this. Okay, this thing. Okay, t is a built-in variable, and the value of that built-in variable is just a symbol, apostrophe t. It's just a symbol t. So it just means true. Okay, that's it. That's all. But so by convention, this t is used for true. Okay, that's all about it. So empty vector, empty string, and the value is 0. They all return true. Okay, let me show you. Actually, we should go faster. Okay, so for example, evaluate it. So evaluate that one. Yes. Evaluate that one. Yes. Evaluate that one. So we got a bunch of yes 4 times. You see. Okay, so that's true and false, and then you have comparison of numbers greater than, less than. That's how you do it, and greater or equal. Okay. Then test equality. Okay, this is also slightly tricky. Okay, there are many functions that test equality. So if you have 2 numbers, you want to use the equal sign to compare them. Okay, so if they are the same, it returns t. T means true. So you can also use them to compare, to test equality between an integer type and a float type. 3 and 3.0 is also true. And if you have strings, you can use string equal to test equality. And otherwise, you can use equal to test equality. so this is the most frequently used function to test equality, is the equal function, okay? Because it covers various different types of data. Then you have something more advanced, EQ and EQL. We are not going to cover them today. Usually you almost never need to use it until after maybe, until 1 year of Emacs Lisp coding or something. Okay, so anyway, for numbers, use the equal sign. For strings, use string equal. And for anything else, generic, just use equal to test equality. Okay. Variables. Okay, so, oh God, it's already 1 hour. It's kind of too slow. I think we are going too slow. So we covered equality. We covered, okay, let's talk about if then else. Okay, so here's the basic syntax for if expression. So yeah, we already showed many of them. So let me talk about, so let's talk about variables. Okay, variables. So in Emacs Lisp, you do not have to declare a variable. You can use a variable right away. And to assign a variable, just say setq x3. Okay. Evaluate it. Okay, that's 3. That's good. Now if you type x and evaluate it 3, so we got x. X value is now 3, and now we can do equal x3 evaluated true. Okay, so this is how you set a variable. And variables by default, if you do it this way, it's always global. Okay, that's always global, known, globally known in every buffer. Okay, let's close that. Let's go back here. Yeah, so let's do it here. Okay, so what else? So that's variable. Let's move on. So what about local variables? Okay, local variable, the way you do it is you use the let function. Okay, so this is a syntax. So if you want x to be a local variable, you put here. Then here you put something body. Okay, that's the whatever Lisp code here. So this variable x will be local to this parenthesized expression. Okay, so for example, let's say message x. Okay, that will print x. Do it. Let's go to the mini buffer. Wait, nil. Okay, nil, because yeah, it's nil because globally x is 3, but locally, that's a local variable. There's no value to it yet, so that's why it's nil. But now you can let's set x equals to 4. Okay, now let's evaluate this block of expression. Do it. You can see it's 4. Now, but globally it's still 3. Let's evaluate this expression. Okay, do it. You see, true. So that's local variable and global variable. So this is how you do local variable. Let. Okay. So let's move on. So there are some variations of the syntax. I won't cover it here, but not now, because we got other things to do. So let me show you about this a block of expressions. So if I have if, let's say if, okay, let's say if x is greater than 2, okay, then do something here, else do something here. So if x is equal than 2, let's say message yes bigger than 2. Okay, otherwise let's say no, not bigger than 2. Okay, let's say no, it is smaller than 2. Okay, now let's evaluate that. You can see the answer is yes, it's bigger than 2. Now what if it's true, I want to do more than that. I want to print something, and I want to insert insert a text into my buffer. Okay, so let's say let's say insert. Okay, insert word. That will insert the word to my buffer. If we do it here, it doesn't work. Why? Because the first expression is taken to be true, then do this expression. Otherwise, this will be done only when it's false. That's how the if statement works. Where is it? You see, that's how if statement works. It basically only takes 3 arguments: test, true body, and false body. So what I want to do is that actually I just want to show you this PROGN, okay, PROGN construct, okay. So that will cut that, put it here. Let's prettify, okay. Now you can see. So this PROGN will group a bunch of expressions into one as one single unit. So now, if I evaluate this if expression, it works. Okay, let's do it. You see, it inserted word here. You see, because it evaluated this whole expression. Okay, so that is why you need this PROGN, grouping of expressions. Okay, so that is explained block of expressions here. So this PROGN is most useful when you have an expression. It's almost always used inside used inside the if statement, if expression. Okay, so actually we got more to cover. So let's do 15 more minutes. We haven't covered defining functions, and we have to cover some basic data, Emacs Lisp data structure. We're gonna cover list and vector, and that's it. Okay, the others you don't have to worry about it. You can worry about them later. So we're gonna cover list and vector, then we're gonna cover defining a function. Okay, then lambda, and that will be it. That would be it. That's all you need to know to begin coding. To be, you already know a lot. That's the fundamentals. After we covered function and list. Okay, let me have a drink, have a minute break. So far so good. Any questions? Okay, there's a question. Can you say about differences between lexical and dynamic scope in Emacs Lisp? That question is actually hard to explain. But let me explain. So let me put it here. So let's lexical scope versus, okay, so let me explain that. This is actually a little bit difficult to demonstrate, but I have something interesting to tell you that I think you will find it useful, because there's a lot of misconceptions particularly in the Lisp community about these things. Okay, so first of all, let me tell you that's an impractical question. Useless, fairly impractical question. Okay, it's like this is one of the dramatic question in programming languages. Very dramatic. You'll see this question. How are they different? What's the benefit? What's the pros and cons? Dynamic scope versus lexical scope. This is one of the dramatic thing among programming languages. All the people will talk about it, but actually in practice, it's not a question. Okay, either your language has one way, you stick with it, things will be fine. Or your language doesn't support one or the other, things are totally fine. I mean, it's not a question where as a practical programmer or a professional programmer, you have to ask about it. Like the question never comes up, almost never comes up. Okay, so it's not a practical question. I hope this is something new. I'm telling you, because if you are a beginner programmer, you'll hear this all the time, and then you'll hear people debate about it. It's a dramatic question. Why is it dramatic? Defined by because it's a question that actually never comes up. Okay, unless when you are designing the language, unless you are designing a programming language. Okay. Now the other thing I want to talk about is that if you are a functional programmer, you'll never actually see any difference between these two scopes. You'll never actually see any difference at all if you are a functional. If you stick to a functional programming principles, that means if your function has no side effect, okay, and you do not use closure, okay, because when you have a closure, your function is no longer a function. Your function has the possibility of side effects. Okay, so don't use closure. Closure is another dramatic thing. So anyway, I'm getting quite out of scope for today's talk because this is a fairly advanced topic. Okay, let me get back to practical. So in Emacs Lisp, before 2015 or so, everything is dynamic scope. Okay, but after 2015, they introduced actually a directive. Okay, so I made a mistake before. There is a directive in Emacs Lisp. Okay, so let me show you. Okay, so about 2015 in Emacs Lisp, every variable is dynamic scope. But after 2015, I think it's 2010. Okay, then they introduced lexical scope. But you have to specify it by, let's go to the eLisp file. Okay, so you have to specify what's a variable. Okay, let's go to one of my packages. That's the easiest way to find out. Okay, go to the top, you can see, close it, there it is. There it is. You see that keyword? There it is. You see, lexical binding true. So that is a variable. Okay, so let's put it here. So there, so that's a variable. So you can now describe variable. Okay, enter, then you'll see the documentation for the variable lexical binding. Okay, so basically this line as a comma, as a comment at the beginning of an Emacs Lisp file will tell Emacs Lisp that for this whole file or the Lisp code, they should be lexical binding, not dynamic. Okay, but okay, mostly there are still some exceptions that's always dynamic binding. Okay, anyway, so you can see the documentation. So it says, the value is nil globally, whether to use lexical binding when evaluating code. The nil means that the code in the current buffer should be evaluated with lexical binding. Okay, this variable is automatically set from the file variables of an interpreted Lisp file, blah blah blah. Okay, so anyway, it doesn't even explain it, but it's hard to explain it because basically lexical binding is text-based variable. So that is what I like to say. What you see is what you get. That's lexical binding, and that's a proper language design. It is so. It began. The language that began this lexical binding is Scheme Lisp. Okay. Then other languages adopted Common Lisp, Emacs Lisp today eventually, but you have to put this line at the beginning of your Lisp file. Okay, I recommend it. Okay, put this line in the beginning of your file. And so anyway, so basically lexical binding. Okay, let me explain. Okay, it's best if we actually demonstrate their differences in code, but it's really hard to do. It's fairly advanced. Okay, this lexical scope basically means text-based variable scope, meaning what you see is what you get, okay? Meaning that a variable scope is inside a paren, inside a syntactic unit of the language, such as paren or bracket in C or JavaScript, so that's lexical binding. What you see is what you get, okay? So for example, we have defined a variable let here that is, if it's lexical scope, that means whatever this x is does not escape this parenthesis, okay? That's lexical scope. But dynamic scope is basically a time-based scope, okay? So this is a time-based scope, meaning that the value of x, a variable, the value of x, a variable, depends on when it is, when the value changed last time. It doesn't depend on how your code looks or the order of the text in your buffer. It doesn't depend on that. The order of, all the brackets, the scope, the nesting of your source code. But rather, it just depends on time. When is something last changed? That value remains, okay? So that's what dynamic scope means, okay? And it would be best to actually demonstrate code to show their difference, but that's difficult because that will involve some, you have to define a function, then you have to let it leak. So basically, it's not a practical question, okay? So if you always write your function, you should always write your function such that it doesn't have any side effect. That is, in other words, your function, the output always depends on the input, nothing else. The same input will generate the same output. That's a function without side effects. For those functions, it is impossible to have these dynamic scope or lexical scope differences. It's impossible to have those differences, okay? Always just do that. Okay, I'm not going to go through. It's hard to do so. Okay. Fantastic, thank you. Okay, so okay, another 10 minutes. So we kind of digressed. Let me show you list and vector. That's the most important. Okay, so now we covered if then else. Okay, there's one more thing, loop. Okay, this is how you do a loop. In every language, you have a loop construct. Okay. Okay, so how do you do a loop? Okay, so loop. So the most common is while loop. Okay, so I have templates. Just don't. Okay, so here's test. Here's body. Okay, that's how you do a loop. So let's test if let's say if while let's put it here, less than, while x is less than 3, okay, then body message x, okay, then but we also want to increase x, so we can say set x equals to plus x1. Okay, that's one easy way to do it, simple way to do it. Okay, so we test if x is less than 3. If so, we print the value of x, then we add 1 to x. Okay, and we want to know what is the current value of x, so we can do that by moving the cursor here and call eval last expression. Okay, let's do it. 3. So right now x is 3. Okay, so if we run this, it won't print anything. Do it. nil. Okay, so we have to say, let's say 9. Okay, now let's do it. Okay, now let's look at the message buffer. There it is. It prints 3, 4, 5, 6, 7, 8. Okay, so this is the most fundamental loop construct in Emacs Lisp. Okay, this is the most basic one. There is no for loop in Emacs Lisp. Basically, this is it. Okay, when you want a loop in Emacs Lisp. Now, of course, there are other kind of equivalent ways to do a loop for, such as for map, and you can also do times. But we are not going to cover it. Yeah, do list and do times. Okay, so let's skip them. Okay, let's talk about list. Okay, list is the fundamental structure. So Lisp stand for list processor. Okay, the Lisp language originally stand for list processor. Okay, that's what LISP stand for. So that's what. So all these are a list. So that's why the whole syntax is all parentheses. That's a list, or everything is a list. So the list is the most fundamental data structure in Lisp. Okay, and the way you generate a list is this. Okay, this is the syntax. Okay, that's a list. Simple enough. Again, remember, let me emphasize what we covered before. Everything is an expression, and the only way you do computation in Lisp, the computational model of Lisp, is by calling a function. So we call a function. So again, we call a function, and you got 3, 4, 5. That's a list. That's how you generate the list. So this is a syntax for a list. Okay, and you can nest them. For example, that. Okay, evaluate it. You see, you got a nested list. You can nest them in any way. Okay, so that's the. Okay, I'm gonna skip some other things. Okay, so if you wanna, you can read my tutorial later for a bit more information. But I'm gonna skip lots of these things. So get a length. So the length, the count of elements is length. Okay. So for example, let's count this list. Okay. So you see the result is 3. So that's list. Okay. Now once you already know how to do a list, the syntax, and then you call a function to do anything with it. So for example, you can get a sublist, you can get and here are examples. You can prepend, you can append, you can join list. Okay, let me show you a few. Okay. Okay, so here is a list, and here is another list. Let's say A, B. Okay, now let's say you want to join them. Okay, so you say concat. I believe that's the function. Append. Okay. Okay, copy that. Okay, so there. So evaluate it. You can see here's a result. Okay, that's how you join two lists. And then you can take a sublist and other things. You can take the first elements, the last elements, and so on. And to check equality, yeah, you can. Okay, so you can use equal to check if two lists have the same number of elements, same items. Okay. So for example, okay, let's copy that. EQAL. Okay, evaluate it. You see, it returns T for true. And it can be nested. Okay, so for example, let's see. You see, the result is also true. Now this is not so for JavaScript. When you have a nested list, there's no way to test the content of a list in JavaScript. You have to write a function to do that. So then you have other functions like push, pop. Okay, I'm not going to cover. Okay, so that's list. Okay, now let me tell you how to map a function to list, because this is important. Okay, so that's how you do it. Okay, so if you want to, let's say you want to add a number, add one to this list. Okay, so what you do is you say map car. Okay, never mind the name. The name is a bit weird because history. But anyway, so you say map car, and the map car takes two arguments. One is a function, one is the list. Okay, so this part is a list, and this part is let's say add one. Okay, so lambda is a function, and now we want to add one. So how do you? So we can say what? Okay, plus x 1. Okay, now if we evaluate this, we're gonna get 4, 5, 6. Okay, do it. You see? Okay, that's how you map a function to every element in a list. Okay, so that's it for that. That's and I'm going to skip vector for now. Now vector is just like a list. Okay, except that the number of items is fixed. You cannot add to it. So it's similar to the concept of tuple in Python. Okay, that's what vector is. Okay, so let me show you how to define a function, and that's it for today. Okay, I'm not gonna cover symbols. Okay, let's see, any other questions? We're gonna shut down in 5 minutes, I think. Okay, so define a function. So you can, to define a function, you say define. Okay, so you say define. Basically here is a basic template. Okay, so here first of all you have a function name, let's say ff. Okay, then you have a parameter, let's say x. Okay, then you have docstring, excuse me, let's say add 1 to x. Okay, then let is again a local variable definition we covered before, and here let's say x plus x1. Let's say add 2 to x. Okay, so that's how you define a function. So now we have to evaluate this, do it. Okay, so now Emacs knows about this function. Now we can call this function ff3. Okay, let's evaluate it. You can see the result is 5. Okay, I think that's how you define a function. And I think we have covered all the fundamental elements of Lisp, the language, and now you can now you can put them together to create however arbitrarily complex programs, because we already know how to do so. We covered the comments, how do you add the comments, how the basics of printing something. We covered how to create a string and all the functions that manipulate string. We covered then we have covered arithmetics. We covered some basics of value type in Emacs Lisp. In particular, we have int, float, and string. Then we covered Boolean. Nil is false, everything else is true. We covered test equality. We covered how do you define a variable, global variable setq, and local variable let. And we covered a block of expressions to group them together for the purpose of if then else. This is conditional, flow control, if then else, critical in every programming language. The most this part, the if statement or if expression, is the most fundamental construct and the most fundamental concept in any programming language. This is the most, because without this, basically you fail tuning machine, or you don't have a transistor in a CPU. So if statement, okay, that's how you do. And okay, so then we also cover how to do loop. The most basic in Lisp is while loop in Emacs Lisp. Okay, then you have variations like do list and do times. Then we covered list, the most fundamental data structure in Emacs Lisp or any Lisp. It's most fundamental because the very name, programming language Lisp, means list processing. So in Lisp, everything you are just processing lists, okay, and everything is an expression. Everything has a value, and the only way you do computation is by calling a function, ahead of a list to get its return value. Okay, so list we covered the most fundamental data structure. Then you can have a lot of, these are kind of details. Then you can have lots of functions that manipulate lists, such as get a sublist, get the first item, get the nth item, push an item to it, or take one item from the first element and remove it. Things like that. Push and pop, very frequently used construct, and lots of reverse list elements, and check if a element exists, a value exists in a list, things like that. So all these are list functions. Okay, then so we covered some of these. We covered the list concept. Then we covered how to define a function. Okay, so this is the skeleton of a function, the most fundamental basic template. Then in the body, you can put any code we covered before, the let variable scope, and to create arbitrary programs. Okay, that's defining a function. We showed some, we demonstrated the use of lambda. Then okay, I think that's it for today. So thank you guys for watching. So when you so there's a question. So when you use setQ on a local variable inside a let expression, does that create a global variable? No. Okay, so let's go to it and see. Okay, so variable. So when you have a let, whatever variable you declare there, it's gonna be local. So inside that, so the set function just sets a value. It doesn't actually create a variable. Well, technically, it does not actually create a variable. Yeah, the variable is created. Let's see. Let me try something. Yeah, well, anyway, that's kind of, some of the technical details, it takes some time to explain. It's hard to explain, but in practice, you don't have to worry about it. So anyway, set just set a value. But if you use it outside of the let, then it does create a variable. Yeah, but it's not really the purpose. For example, it's not really the purpose of set. For example, let's look at the documentation for setQ to see if it actually mention it actually create a variable. Set each symbol to the value. The symbol sim are variables. They are literal. Okay, the value, they don't mention anything about creating a global variable. That's just a side effect. That's Yeah. Yeah, they didn't mention about it creating a global variable, but it actually does. But that's not its job. Okay, so that's it. I think that's it. Okay, so everything we talked about today is already, in my tutorial, of course. If you like my stuff, sponsor me, okay? Pay me. Buy my tutorial as a donation. You get the whole, 7,700 pages of tutorial, on your hard drive. So, okay, that's it for today. 90 minutes. Bye, guys. Okay, there's a question about byte compile Lisp. Okay, let me talk about that. So let's look at our Lisp code. Okay, so we got a bunch of Lisp code here. That's what we talked today. Some of them are just not actually valid. For example, that one, because f is not defined. So let's comment those out and comment those out. So we are going to create a valid Emacs Lisp file here. Okay, so we're gonna. So this is a valid Emacs Lisp file. All those are valid Emacs Lisp code, and all that. Okay, so here's a valid Lisp file. So you can see that's a file. We can compile it. So in diode. So let me show you. So, if you know Emacs, this is diode. Okay, so I can press capital B. Then Emacs asks me, do you want to byte compile it? Yes. Type Y for yes. Okay. Then it gives me a bunch of warnings. Okay. Warning: value return is not used. Yeah, value return is not used. Something is not used. Is not. Yeah, because this is kind of silly examples of tutorial. We are not actually, the code does not actually do anything. It just return a value that's never used. So it gives you a bunch of warnings when you compile. Press B to compile in diode. Okay, or you can meta X and say byte compile file. Okay, call that command. Then it'll ask you to type a file path. Then you'll compile it. Okay, so Emacs Lisp. So you have a byte. You can byte compile the Emacs Lisp code. So why do you need to do that? You don't need to do that. But if you do that, Emacs, you can load the byte compiled version, and it will be faster. Okay, Emacs will be able to run it faster and also load it faster. That's basically the only advantage. Okay, other than that, so if we can open it, this is how it looks like. It's it's a sequence of bytes. So this is intermediate code. In computer science, it's part of it. In essence, the byte compiled file is a side effect of computer engineering. Okay, mathematically, practically, math is useless. Okay, technically we don't need it, but however, it's because engineering, you have lots of technicalities and details and the way to make things fast, use less memory, and so on. That's why you have this intermediate concept of byte compiled thing, which is a hindrance. Technically, it's a hindrance. You shouldn't have it, but because of reality, the real world situation, so you have the byte compile thing. So you can byte compile any Emacs Lisp source code to create a byte compile file, and it'll load faster and run faster. Okay, that's it. I think about 5 times, according to Emacs Lisp manual, which haven't been updated for a long time, it says like 6 times faster or something. Anyway, I'm not. Anyway, that's it. Bye, guys. Buy my tutorial. Okay. Bye, guys.